Today I'm going to talk about the follow-up of HTTP, a very exciting subject. I didn't realize it was this exciting. Full room. Is this going to work? Yeah, so I was thinking about these headphones. I really don't like that you can hear me, but we are not having I'm used to more interaction. So I thought that problem, solving it this way, is like solving telephone number input like this. It works, but it's not very ideal. But it works. See, you're not laughing. You would be laughing if you didn't have a headphone on. Anyway, oh, you are. About me, this is my favorite slide. My name is Piet. This is the second most Dutch name you can have. My father has the same name. I'm a software engineer at Luminis. I'm senior, but I'm a full stack engineer, and next year I'm going to be something else, but doing the same stuff. And I think that people matter more than technology, as you all do, of course. I also before I became a programmer, I was almost a teacher. I do have the paper, but I don't care about, oh no, I do care about people. They are more important than technology, but I'm still a programmer. And usually I had this line where I stated that I'm a runner and I play football, but I don't. So this is a reminder for myself to start running again. Oh, and my Twitter handle didn't work on the app, so this is my Twitter handle. If you would all follow me, great. Okay, so what are we going to do? I'm going to introduce this, which I'm already doing. Then we'll try to dive into the theory behind HTTP2, and then do some practice, because the talk was in action. I also submitted a more drier talk, but they didn't accept it, so I have to do some coding. And then we're going to see the code run, and then I'm going to answer questions. I promise I will be on time. So 12:05, you can ask questions, +1, and then you can eat. Okay, so in perspective, who saw the talk about gRPC yesterday? Okay, so you already have seen half of my talk, so you can relax now. There was also a bit about the history of HTTP2, but it started in 1991, and I disagree. That's not the start of the development of HTTP. When I explain that, we're going to zoom in on the actual technology behind this new protocol, and then only then answer why, in the first place, do this. Because we are programmers, we first make something, and then we try to say why we did it, or come up with an excuse. And then I'm going to show some new features. Okay, a bit of history. So, you didn't expect this, right? 50 years before the guy from yesterday, in 1941, around this time, the idea of a hypertext transfer protocol started. And the background shows something that happened that year. Something happened this year. And it was a very violent time. And Jorge, or George, no. He wrote a fictional a story, a fiction, The Garden of Forking Paths, in which a character had this unlimited amount of timelines which he could choose. So it is a little bit like those stories where you can pick your own ending. And that was called hypertext fiction. Maybe not then, but it was called this after the fact. So this was already an example of what you can do with hypertext. Then 4 years later, Vannevar Bush wrote As We May Think, which is an essay about some sort of computing device, a memex, in which you can store everything we know. So his idea was that instead of creating technology to destroy things, like you can see in the background, which we were very good at, he said, no, we should focus on creating stuff that will help us further as humanity. So that's why he thought about a memex. And he predicted that this would lead to a knowledge explosion. And that's exactly what it did. So I think it's a smart move. Then we skip a few years. Then 3 guys at the same time invented about the same idea. Douglas Engelbart invented or created the online system, and at almost the same time, Ted Nelson created or coined hypertext and hypermedia as the definitions we know today. And together with Andries van Dam, he created a hypertext editing system, which is kind of like what you do if you make a HTML page or a web page. And then in 1968, Douglas did the mother of all demos. Has anyone heard about the mother of all demos? So that was a demo in which, cool, now you all do. He demonstrated a computer with a graphical user interface, a mouse and a keyboard, which was totally new by then, and which still is the way we use computers, or the way we interact with them. And then Ted Nelson thought, I can do this too. And he did something less exciting, but still very cool. A file retrieval and editing system, which is exactly as it says. Then, new Pope, 1978. DARPA, or ARPA, it was called then, the Defense Funding Mechanism, I don't know what it is, in America. They funded the Aspen movie map, a sort of interactive map of Aspen, which kind of looks like the things that the Encarta Encyclopedia had when I was young, which was actually the first hypermedia system, because you could interact with a map and you could see pictures when you wanted them. Then, 2 years later, Sir Tim Berners-Lee, as we all know, thinks up Enquire, or a wiki at Enquire. No, it's called Enquire. And Peter J. Brown thinks of roughly the same idea, a guide. And an Italian monk, I think, conjures the Index Thomisticus, which is a sort of web page of very old stories. Then, 3 years later, my birth year, the interactive encyclopedia system is invented. Well, it's, as you can see, it's roughly the same ideas reinvented every time, but they are following up much sooner. And eventually, in '87, there's something with stocks, but also Apple created the HyperCard software, which is kind of like a web page editing system. StorySpace is the first application in which you can create hypertext. So that's 46 years later. It's possible to actually create something like the Garden of Forking Paths. So it takes a while. Then, 1989, something with a wall. And the World Wide Web is coined, the term, by Tim Berners-Lee again, while he was working at CERN. And he defined what hypertext is. So a text in which you can link to other texts. And he thought, well, if you can do that, then you could also link to other computers in the same network. So you don't have to have all the information on your computer. You can just link to another one, which is a very good idea, and which is exactly what the internet is now. He also invented something with which you could browse these knowledge articles. A browser, good name. Anyway, then this was standardized in 1991. The first version of the HTTP protocol, it was actually in use, but then it was standardized. The TCP/IP connections were standardized with them. And the first definition of the protocol defined a GET request, as we all know. It's still in use today, and a response. So you get a resource, an address, and you ask for a resource and you get a response. And then after the transfer, the connection was closed. Then, a few years later, there was a disaster in Amsterdam with a plane in the Bijlmer, but also the Lynx browser was invented, which was, well, we would call this the birth of the internet, because regular people could connect with each other on the internet. And in that year, we had 500 web servers, so you could map the internet. But a year later, we had 10,000 web servers. So that's an explosion of information, exactly as the guy whose name I forgot, predicted. And the W3C was founded, still working today as it was supposed to then in 1995, something in Oklahoma, and HTTP 1.0 was defined. It wasn't a formal specification, but it was used anyhow because the developments were very rapid in this year. Some new additions to HTTP were conjured, like a version number, a new request, headers, status codes, and a new method options. Then a year later, already a new version, 1.1, a mad cow in the background. Then we had an Arena browser, Netscape, Mosaic, Internet Explorer 2, and in March already 40% of the browsers complied to the new standard, and in June 65. That's very fast adoption. Then a year later, HTTP 1.1 is re-standardized, a new version of it is written down, and I think this is the version roughly still in use today. So that's 20 years ago. There's a new required header, the host, for the host name, and now you could keep the connections open, so you don't have to open a connection for every request you do, because by this time, images were also embedded into websites, and maybe some music or GIFs, or if they existed already. And caching was improved, was very necessary by then, and some other small stuff. What happened in 1999? I couldn't find anything but SpongeBob, which is pretty major, but still. The tone was very serious, but maybe SpongeBob is very serious, I don't know. Anyway, that's a jump of 8 years, 2007, a new head of UN, I think, and a working group takes 7 years to improve HTTP 1.1. And Google said, that's a long time, we're going to do it better and faster. So they developed Speedy, and if you attended the talk about gRPC yesterday, you would know that most of Speedy is also in HTTP 2. It is used as a basis for HTTP 2. Or as Google would call it, HTTP 2 is invented by Google. On the background, if you're Dutch, you will recognize our Prime Minister and Geert Wilders. And our administration fell by then, and Mark Rutte said to him, I'm going to destroy that little party of yours. Well, that didn't happen, if you follow Dutch politics. Anyway, 2 years ago, HTTP 2 was standardized, and Pluto was photographed. Super exciting. Okay, still with me? Hungry still? Okay, then another dry subject, the technology behind the new standard. So, just to refresh your memory, or to learn you something new, the definition is hypertext transfer protocol. The hypertext is just text with links. And links are links to nodes or the same node. Then the protocol is used to transfer this text. That's the protocol part. And TCP/IP is the Internet Protocol Suite, which you can see on the right-hand side. So you know the OSI layers. This is another view of those same layers, but simplified. So you have the Ethernet layer, the link layer, then the Internet layer, and on top of that you have the transport of the actual application. And that's where HTTP is living. In the top layer. So from a bird's eye view, how does this protocol work? So you have a client, a browser, or a curl, or whatever, and you just do a GET request, or a POST request, or a PUT request to a server, to an address. So you have a verb, GET, PUT, POST, and you have an address, a host name, www.example.com, and that's it. So the server gets this request, it's routed to the server answers with a standardized response. If it's OK response, it's in the 200 range. As you all know, 404 if something went wrong, or on the server side, 500. And this is a very simple protocol, and I think that's why it's so successful. And resources are identified by URLs, as we all know. So you have these are the parts that a URL has. OK, so this is literally a request. So this is if you type in example.com in your browser, then this is what gets sent to the server. This is just plain text, or scrambled if you encrypt it, and the server just sees this. And the server thinks, OK, I'm going to respond with HTML, for example, in this case. So it says, this request went well, 200, OK. This is the version of HTTP I'm using. The content is about this size, or is exactly this size, and it's text. And then it has a new line, and then you get the actual information, which you can see if you press right-click, view source, and you see this. So you see a huge Hello World title. OK, so that's HTTP 1.1, still in use today. Now something about the the reasoning behind. Oh, I can see my screen here as well. Cool. I still don't have to look at you then. Oh yeah, right. So something is wrong with it. Nothing is wrong with HTTP 1.1 per se, but the way we use it is not the way the usage was intended. Because when Netscape, I don't know, 1.0 was invented, you just had text and a few links, not even images, not style sheets, just text. So there's one request, one response, close the connection, that's it. So there's good requirement analysis, and why would you do more than that, my architect would say. So, but by now, you know, the web is misused or used for something quite differently. So you do a request for a slash, and then you get 500 images, style sheets, JavaScript, and that's not what the original protocol had in mind. So this is causing congestion on the network. There are all kinds of hacks to prevent this from being too slow. So if you open your Chrome browser and go to twitter.com, you have 5 concurrent connections that retrieve resources at one time. So you have 5 open connections on your network. If you work in an office space, every time someone does a request, you have 5, 10, 15 open connections. That's not very fair to the rest of the network, so that's a problem. And the problem is still growing. As you can see, this was a month ago. The amount of requests per website, the amount of data, the amount of files that get transferred is still growing, which is problematic. Okay, so that's why HTTP2 was invented. And how is it going to solve this problem? Well, first of all, HTTP2 is no longer plain text, which is kind of a shame, because if I would teach a student how HTTP2 works, I can just tell him, go to curl, type in a web page, and see the response, because it's all binary now. But it's very efficient for machines. So you have fewer errors because it's hard to parse, so you probably use a library, which is, of course, perfect. It's more efficient because it's all computer language. And another feature is multiplexing, which I'm going to demo in a few minutes. But the gist of it is that it doesn't have any ordering, so requests or responses can come in any order, interleaved as well. It's non-blocking, so you have an open connection, you get everything at once. There's less congestion because you only use one connection for each request-response cycle. What's also new is header compression. I'm going to demo that in a few, which is more compact, so less data over the line. And something which got me into researching HTTP2 was server push. So now you know, if some user goes to your web page, you know he's going to also request a CSS file, an image, JavaScript. And right now, with HTTP 1.1, you have to wait for them to request it. They have to parse the HTML, see, oh, there's a style sheet I also need, do a request, and it takes a while for your page to load this way. What's also very important is that this protocol is compatible with 1.1, the previous version, because as we all know, you're not going to get some adoption if you don't support the old version. Angular. Okay, new features. What's new? So, the first thing is the binary protocol. So you used to have just HTTP on the top layer, plain text, but now, because it's more compact, there's some kind of intermediate layer living in the top layer, and it contains frames. So you get header frames, so that's the top part before the new line in the old protocol, and you get data frames. And this is important because headers are compactor and they are parsed differently than they were now. Then we have a new way of doing a request-response cycle. It's now called a stream. So you set up a stream, you open a stream to the server, and in that stream, one connection, you send stuff and you receive stuff. So it's bidirectional, as you can see, and it's just a flow of bytes. You don't see anything if you debug it, and it contains a or several messages. So this is the stream. Then you have messages. Every block is every color group is a message. So this is one message, this is one message. And once all frames, so that's the smallest unit, are in the system, then you have received one entire message. So that's smallest, that's the typo unit, the smallest unit of communication, and it references a stream. So you need to know which stream this belongs to, otherwise your message won't get received. Okay, so let's, let me see. Yeah, okay, so a little bit more theory and then we're gonna do the in-action part. So what I mentioned before, multiplexing. Now let's do it now. Okay, I think I need some volunteers. So let's do a live server client demo. So and let's demonstrate the. Does anyone know what the head of line blocking problem is in HTTP? No? Okay, cool. Then we're going to demonstrate it. So I have a request and a response. So can I give you the response for this? For resource number 3. Okay. And then for this part, resource response, can I give it to you? Response number 2, and then 3 has to be all the way in the back. Let's pretend this is the response. So can I give this to you? Okay, and then I'm gonna play a client, and you are gonna play response. Okay? So I'm a web client, so a browser, and I'm gonna request. Oh, I think I messed up somewhere. Anyway, so I'm gonna request 3 resources. Resource 1, this is the first resource I request. 2, so you have 3, right? Okay. So so will resource 1, 2, and 3 in that order come to me, please? So first resource 1, can you come to me? That's you. Can you come here, please? Yeah? Can you give that thing to me? So, and she's very close, resource number 3, but she has to wait for resource number 1 to reach me. And you're not running. Thanks.
And I'm not number 1.
Oh, are you number 1?
No.
Oh, no, you're not. Oh, sorry. I thought you were number 1. Let's pretend you were number 1. We didn't hear this. Thanks for volunteering. Okay, then resource number 2. Yay, was still fairly close, but behind you. And then number 3. Thank you. So this is actually how a web server works and how HTTP 1.1 works. So because you were the first resource I required, I had to wait for you to arrive, and then number 2, and then number 3. This is actually how this works. So if a resource is slow, for example, if you request HTML that has to be parsed on the server while images are already in cache, you still have to wait. So HTTP2 solved this by multiplexing. So I request something. So I send a stream of, or actually a header stream, for example, for stream 1. And then I'm gonna also request stream 2 and 3. So that's like a resource 2 and 3. And the server receives this request and just sends everything at once, but not in. So I want to demonstrate this as well, but I have to. Yeah. This is okay. So I need a volunteer. Can someone come to the stage, please? I did this last time at a brain upgrade of ours. It didn't go very well, so I made some preparations. Yes. For this, yes, this also is very important. We don't want to get people sick. And yeah, for the screaming. Okay. So can I have a volunteer? What? It's not okay? No, oh. Can't do this. Oh, okay. Then, but then it will be very dry. Okay, it wasn't me. Did you have that? So it's the fault of the organizers. I'll try to explain it without any bloodshed. So maybe we can do it after outside. Okay, so what multiplexing is you request 3 resources, and the server receives this, and this is what the server does. Then it's still in action. So it gives you everything And the client just has to pick this all up and put things together. So these are the same requests. So now I'm complete. No, I'm not. So this is the whole response. So now I can show this response. And this is OK. Now I can show this, which is very efficient because you can just receive things not in order, but still very fast. And I'll also demonstrate this, by the way, in a few minutes. Then, server push, which is a very cool feature. So, like I said, you request a resource. Your application or your server already knows if you request the index file, you also need images, JavaScript, style sheets, and it just gives you a push promise, as you can see here. So a promise is a way to tell your client, I have something for you that you will need. And if the client says, OK, give it to me, then it will be sent right away. I thought this was a very cool feature, but it doesn't work in practice as I think it would work, which I will demonstrate. OK, then header compression. OK. Header compression is a way to compress headers. So usually, or in HTTP 1.1, you send all headers every time. HTTP 2 says we only diff what you sent, the second and the third request, which is very efficient. You only send what's changed, and you keep an index of what you already needed. And lastly, a cool feature is that you can negotiate which protocol to use. So you can just use HTTP 2. If a client doesn't support it, you fall back to HTTP 1. And the last not so cool feature is that you can still say this resource is more important than the other one. Oh, I already showed you some action. Thanks. OK. There's fashion, short pants. I can't get normal pants anymore. So I'm going to show an actual HTTP 2 server now. I made it, I didn't really make it. I programmed it. I glued it together with Vertex. And at the end, I'm going to do the question round in 7 minutes, and then you can lunch. OK, so this is not very interesting. But these sheets will show you, if you download them later, what servers already support HTTP 2, which is almost all servers, and which version and negotiation protocol they use, and clients. Every browser supports HTTP 2. That's all you wanted to know. OK, so now the exciting part. I have a Java development kit on my machine. I have imported Vertex, the reactive application toolkit. Then I have some static linking, which is not necessary in Java 9, but I have to mention it still. I have some files that I will gonna respond with, and a build tool and a browser. So the application I'm going to show has 4 resources: the index, images, style sheet, and a JavaScript file, which are going to be pushed, because I know if you want to build up the index, you need these resources. And if you want to, you can find this demo at my GitHub. You can start it, or you can't. OK, so this is my server. I imported Vertex, as you can see here. And oh, by the way, HTTP 2 is inherently secure, because no browser supports HTTP 2 without secure connection. So I have to do some key store configuration. I use the negotiation. Can you see this, by the way, in the back? Yeah? OK, I use the negotiation protocol, use SSL. Then I define 4 resources. They have a path, the resource on the server. And then I'm mapping them. This is all Java bullshit. OK, then Vertex. I love Java, by the way. Vertex, I'm going to build. So this is it. This is all behind some magic curtain. Then I'm going to create a server with the options I just mentioned. And I'm going to define a request handler and listen on 8080. So the request handler is here. So every time I get a request, I'm going to look which path am I requesting, so slash or slash index.html. Then I'm going to try to get that resource. And if it is available, then I'm going to either just send it or push it. So if I get a request for the HTML file, I'm going to push also the style sheet, the image, and the JavaScript file, as you can see here. And pushing is done like this. So you get the result, and you do a push response with the file. So if you want to look it up in your own time, go to my GitHub page, and you can run it as well. I also have a Docker container because it's super hip. Was it still? Okay, so now I'm running this application, and this is the result. And it was super fast because it's local. So this is an index file. It's styled with the style sheets, and it has an image, as you can see here in the background. And it also has JavaScript. See, it says hello console. So what happened? Can I zoom in? Yes. So I'm going to refresh the page, and then you can see what happens. So I'm requesting localhost. I'm getting a status 200 response with the HTTP2 protocol. The browser initiated this request, as you can see. And then what happened was my server responded with 3 push promises, as you can see here. So this is not initiated, this request by the browser, but by a push promise. And in this case, Chrome doesn't immediately ask for those resources, which I expected when I tried to look into HTTP2, but it delays the getting of these resources when it is sure that they are needed. I don't know why. I guess it has something to do with performance or security, but I expected that Chrome immediately would load this and then at once have the whole web page, but it doesn't. But if you're making your own client, you can, of course, always try to deliver on a push requirement. So it works. Let's continue. Launch. Oh, right. So why is this then for you, or why is this important to know, or what's improving now? Push doesn't work as you expected. So in HTTP 1.1, in a perfect world, this was what happened. You get a request, or do a request, get a response, or see, oh, I have to do another one, get another one, etc. There's also something called pipelining in HTTP 1.1, but you still have to wait for the for your resource to be requested by the server. In HTTP 2, you do multiplexing, so you request something and another thing and another thing, and they all come in when they are ready, which has about the same performance as pipelining in HTTP 1.1 on a perfect network. And with push, you would expect this, but that's not always the case, as you saw. Okay, so where does HTTP 2 shine? So if you have a high latency network, for example, if you are on mobile in a field or in a country where they don't have great networks, then HTTP 2 comes to the rescue. Because if you have a lot of delay in your response request cycle, then multiplexing will at least help you when you request 2 resources. They will at least come in at the same time. And in HTTP 1.1, you have to wait for this resource to come in, and then the other one would follow. So that's where it would shine. If you use push, it would be even better. So to demonstrate this, there's a URL, Govertiles, this URL, and it emulates what would happen on a bad network. So with HTTP 1.1 on a perfect network, this happens. So this image gets loaded. They come in the order I requested, and with HTTP 2 on a perfect network, we see about the same, but still faster. You can see that it gets all the resources immediately. And in 1, they are sequential. Then if you have a lot of latency, for example, 200 milliseconds, this happens with 1.1. So you have to wait for, so you send a request in order, and the time between those requests is always 200 milliseconds, and that's also the delay you will get when you receive them. In HTTP 2, you send all these requests at once. Then it takes 200 milliseconds for the request to arrive on the server, but the server can immediately send everything back. So this is the result then. If we exaggerate it to 1 second, so 1.1, if you have a delay of 1 second between request response, then this will happen if you use the old protocol. Stop it. And in 2, it takes 1 second, but then you get everything back at once. So this is the actual power of 2. Oh, yes. Okay, so what do I recommend to you? Just use this protocol. but there are some caveats, small ones. So you're not sure if your client supports it. Right now, if you're making a web page, you can use it, but there are some, well, you still have to do, for example, concatenation of your files, minification, because if your server doesn't support 2, then you're still going to have performance problems. But if you're behind, for example, if you're making microservices that interact with each other, then you know what your clients and servers support, then I would switch over immediately, like gRPC does. Oh, and don't forget to read the documentation. For example, if I had read the documentation, I would know that push wouldn't work like I was expecting. If you want more information, you can go here. Okay, now questions. I have to put on my headphone, and you get a mic if you have questions. Oh, I can hear myself. Oh, that sucks. Do I sound like this?
Hello.
Hello.
Good morning.
Good morning.
I'm doing
Afternoon.
research on energy efficiency of mobile applications and mobile browsers.
Yeah.
I'd like to know how HTTP2 may impact the energy consumption of the mobile app or mobile browser running on the mobile device.
Well, that depends on the implementation of the client. But I would guess that if you have a bad network, for example, you need less time to wait for a resource, and that time you don't need to keep the browser open, so that would be a pro. And the TLS or the security on top of the protocol is also present in 1.1, so that's not battery consuming either. And furthermore, I don't see any, well, maybe the HPACK algorithm uses more CPU power, for example, but it's very efficient. So I don't think it you would notice the impact. I think. Let me. Is your question answered? Yeah. Okay. Anyone? You want lunch, but he's the guy that is preventing you from getting lunch. What?
Hi, thanks for your presentation. I want to know how HTTP2 handles cached resources. For instance, you have a JS file that is cached, so you are always sending the JS file?
No, the protocol is backwards compatible, so things like e-tag headers you can still use. So you can still send caching hints, for example, e-tags or time to live, and the browser will accept those. So if the time to live is until tomorrow, the browser, the client, won't request the resource anymore. So nothing changed there.
Well, but if you are doing push, you are always sending the resource, right?
No, you are sending a push promise, so the browser knows which resource you are going to deliver. But if he already has it, it doesn't have to request it anymore. So it just doesn't try to get the resource anymore. It just doesn't ask for the delivery, and the server doesn't push it then. So the client has to actually request it still.
Ah, still. Okay. Thank you.
By the way, if you have more questions, I'm at the Luminous stand there in the hall. And you can email me, Twitter me, come by.
Also, thank you for your presentation. For example, what you see these days in HTTP 1.1 protocol when, for example, lane binding is initiated, like a jQuery, for example. It's like a chain reaction of JavaScript files calling each other and waiting for the load. And you see that really nice as well in the Chrome development tools thing. How would the HTTP2 be different to that? Would it actually combine that and have it all weighted combined like with the promise you said, so it will return the result anyway, or is still like the waiting?
Well, that depends. If you, for example, if you have a head in your HTML with 500 JS files, then your browser knows I have to request those, so it sends the request immediately and you get them back as soon as possible. But for example, if you do lazy loading or something, if you have a module system where the module is only requested when the code is executed,
lane binding,
then you have the same problem.
Same problem, yeah. Like we do it on the other side around. Like we grab web pages basically, And one of the problems is if you would like to do it and try to copy the behavior of a regular browser, you have to also install maybe a part of Phantom.js in order to execute those kind of codes.
Yeah.
I think you still need that for HTTP2 then, right?
Yeah, you do, and I think the late binding isn't that an optimization to get around the problems HTTP 1.1 creates.
Yeah.
So once you are switched to HTTP 2, you won't need that anymore. You just send all modules.
So you basically can do like perform an HTTP2 request and then wait if the server is compatible with that. If not, you have like a second, an alternative schedule. You could maybe try it.
You have this protocol where the server tries to request using HTTP 1.1.
Yeah.
Oh, here. And if it doesn't support it, then it switches back to HTTP 1.1. Yeah. So you can do some. You could do some intelligence on your server. Yeah. You could deploy a different application for a different protocol, but that you need to hack your server or at least do a lot of configuration.
Yeah, and maybe filter out the stuff you probably don't want, like images or anything else.
Yeah, yeah. We are in a time where we are. I think 40% or something of the web is using 2. So you have to look at your use case. Maybe look into your browser usage.
A lot of thought to get back to work with. Thank you.
Yeah. Let's not do any more questions. Let's do lunch. And if you want to ask me more, then I'm in the hall. Thank you for joining.